So if you watched my previous lecture just now, talking about TCP/IP version 4, where I kind of left off was that in the 90s they were running out of addresses. By 1994 they were already trying to create a new version of TCP/IP that was going to give them a lot more addresses. Okay, and of course with TCP/IP version 6 they were going to get 128-bit addressing system. So TCP/IP version 6 is a 128-bit addressing system, whereas 4 was only a 32-bit addressing system. Okay, now if you think about that and you do the math on that, you come over here to my calculator. With version 4, I was going to get 4.3 billion addresses, but with version 6, if I do 2 to the power of 128, I would get this crazy number here that's 38 digits long, which actually it's actually 340 undecillion combinations. Okay, now I know you guys probably think I'm making that up. That's actually a real number. Okay, 340 undecillion combinations. Now what does that mean? Well, essentially what that means is a lot of times people will joke and they'll say, oh, every man, woman, and child could have like 10 IP addresses and we still wouldn't run out of addresses. Actually, every man, woman, and child on this planet right now could have an IP address for every hair on their body, okay, and they would only be using almost half of those addresses. Almost half, okay? So that should tell you something. There is a lot of addresses in version 6. Of course, as I always like to say, is there's one thing we learn from history, it's that we don't learn from history, right? We'll probably still end up running out in 10 years from now or something. But anyway, here's the problem. In 1994, they weren't ready. They were standardized and they were trying to figure it all out. They weren't going to be able to do it in time. The internet was growing leaps and bounds. So what happened? Well, what happened is this thing called NAT got implemented. Network Address Translation. Okay, so I want to just quickly give you a drawing and show you what NAT did. Let's look at the way things were for companies before NAT came out. So before NAT ever came out, you needed a router. Okay, that's still true today. We got to have a router. Okay, so we're going to say this little device here is our router. Okay, and of course our ISP would give us a connection into our company. This little cloud symbol that I'm making here is going to represent my internet connection. Just kind of cleaning it up a little bit. All right. And so we've got our internet coming into our router, okay? So even in the 90s, we had to come in through a router. Of course, some of you guys may say, well, I had a dial-up connection. Well, so did I. I know what you're talking about. But I did work for a company in the 90s that had a router. If you were a company and you had a large amount of computers trying to get out to the internet and stuff, you generally would have a router, okay? And then we're going to have another device over here called a switch, okay? Of course, in the 1990s, it was probably going to be a hub. Switches didn't come out until the late 90s. Switches give you a much better performance and security on a network. Again, not to turn this into a networking 101, but clients normally connect to your switch. Okay, so I might have, let's say I've got these 3 devices here and here. These are network cables plugging into the switch. Okay, and let's say that this is 1,000 computers we're looking at here. 1,000 computers. Okay, I'm not going to draw 1,000 boxes, obviously, but each computer needs an IP address. Well, your ISP would give you an address. I'm just going to make up an address right here. Here's an address I'm just making up. And your ISP would also have to provide you with addresses for your other computers. So that's when you would end up purchasing or leasing a large amount of addresses, which is where you spend money, and they end up giving you way more than you need in the 1990s. And this is where things got mismanaged. Okay, so the problem is before before in the 1990s, I was trying to get all these computers out to the internet. I would need over 1,000 addresses to do that. Okay, over 1,000. So the world's stock of IP addresses were being used up. Right now, what happened was in 1998, these 3 guys, one worked for Intel, one worked for IBM, one worked for Cisco. They came together and they created a protocol called NAT. NAT is a routing protocol, okay, and it can allow routers to separate things into 2 different networks. You can separate your internal network away from the internet. The internal network is called the private network, and the internet is called the public network. Okay, so it separates those two things. Now, of course, in order to do that, they did have to reserve some IP addresses from the internet that can be used internally. These IP addresses are called the private IP ranges. And here's what the private IP ranges are. 10.x.x.x. Okay, the X's, you can do whatever you want with those X's. You can set the addresses to whatever you want. 172.16.x.x. That's not the whole range, but you can also change the X's on that. And then you had 192.168.x.x. Okay, and so those are your three main private IP ranges. There was another range that was reserved called 169.254.x.x, and that's for something called APIPA that I'll get into later. Okay, but these are your three ranges. Now the beauty of this is every person on the planet, every company on the planet, everybody can use these addresses on their internal network. Everybody can. So I could give my router, for example, 10.0.0.1 internally. So my router has at least two interfaces there, a private interface and a public interface. I can give my clients internally here each one of these addresses. Okay, maybe this server right here. Okay, and now the beauty of it is I get all 1,000 of my computers out to the internet, but I only needed one public address, just one. So when this came out in 1998, this dramatically changed everything. Okay, all right. And so now today, lots and lots of people use NAT. Of course, if you fast forward about 10 years, by the year 2008, we were starting to run out of addresses again, even with the help of NAT. And then, of course, what happened was IP version 6 was out, and a lot of your ISPs were able to transition over that, which bought back millions and millions and millions of addresses. And then companies like Facebook and Google that use large amounts of addresses, they've moved a lot of their infrastructure over. So TCP/IP version 4 has been able to continue longer than it probably should have continued. IP version 6 honestly is a better routing system. It is a better, more secure. It uses IPsec for its encryption. We don't really talk about IP6 here. That's not something that's tested on the MD100. We're just kind of focusing on the topics that we need to focus on here. But it is a much more secure, much better hierarchical system than just what version 4 originally was. But the majority of the world is still just using version 4. Okay, now one more thing I want to say. NAT is a routing protocol, but there is something else you can put in at a company as opposed to just using NAT by itself. A lot of companies have implemented something called a proxy server. Proxy servers are also sometimes referred to as a web security gateway. So you can buy these as appliances, and they're called web security gateways. Okay, so instead of a router doing NAT, I could actually get what is known as a proxy server that's going to perform NAT for me. Okay, and that proxy server will basically do the same thing as NAT. Proxies, though, one thing that's neat about them is that they can do a lot of jobs. Okay, proxy servers can be a firewall for you. They can even be what's called an application layer firewall. Proxy servers can actually support VPN. Proxy servers can do NAT, okay, obviously. Proxy servers can do routing functionality, and one of the big things it does is it can do something called web caching as well as URL control. Okay, so what does all that mean? Okay, well, firewall, we're going to be discussing firewalls in one of our later discussions, or previous discussion, I'm sorry, we've talked about it previously. VPN, we're going to talk about that coming up. NAT, we're talking about now, routers, route traffic, web caching, and URL control. Now, those two things. Web caching makes it where when one person goes out to a website, okay, NAT, with the help of NAT's going to transition it from private to public and allow it to go out to the internet, okay? But here's the beauty of it. If this person right here was to go to that same website, the proxy server has already cached all the images and text and stuff. So it actually gives you the simulation of having a faster internet connection. It preserves your internet connection, so it helps improve your performance. The other thing is URL control, Uniform Resource Locator Control. That can police where people are going on the internet. You can, with proxy servers, you can You can stop people from going to certain websites and all of that. So this is one of the big benefits of a proxy server. I'll also be showing you how to configure the proxy settings on Windows 10 coming up. But hopefully that gives you guys an understanding of what NAT does, the concept of proxy server, and you understand kind of what the history a little bit of where things were and how we ended up where we are. Okay, and I'm also going to again give you guys some hands-on. I'm going to go through some demonstrations here coming up.